Alrighty, so today we're looking at chapter 5F, solving equations by performing the same operation on both sides. So just from the title here, I can see that we're solving equations. So that means we're trying to find what does the x equal, what does the y equal. So we're trying to find the variables. We're solving it so that there aren't any variables so that we know them. And we do that by performing the same operation, okay, on both sides. So to keep an equation equal, you have to do the same thing to both sides, okay? Because usually if you have, let's say, 2x equals 3, okay? If you perform an operation, let's say times 3 to this side, so 2x times 3 is 6x equals 3, okay? What that does is actually give you two different equations now, okay, because you haven't done it to the other side. Now, this might not make sense at the moment, but we're about to go through why. All right, so some key ideas here. To solve an equation using the balance method, so like I said before, we're keeping both sides of the equation equal. You have to use the balance method, perform operations on both sides of the equation to produce equivalent equations, which means they equal the same thing, until you obtain the solution equation. So x equals so-and-so, or you might be finding a. So we're going to try and find that variable. So we always want to end up with an x equals something, or y equals something. An operation can be undone by performing the inverse operation. You can use a simplified flowchart to decide the order of operations to undo. So like the chapter before, we were using flowcharts to find out, which operation comes first when we're applying it to the variable. And we need to backtrack, so use our inverse operations in order to do so. So remember that inverse means, what's the opposite of adding? We subtract, which means the opposite of subtracting is plus. The inverse of multiplying is divide, and the inverse or opposite of dividing is times. All right, so that's really important to know. If you're not sure, where to start, then you can do your flowcharts like you've learnt before, but hopefully we're getting you to a point where you don't need to use those anymore. All right, so let's start off with some solving equations and using the one step. So there's only one thing we need to do for each equation. Okay, so with A, we've got x plus 7 equals 12. So at the moment, like we said earlier in the key ideas, we want to get x equals, and we want an answer. We want to solve what does x equal. Now, to do that, a lot of you will look at this and just by inspection, okay, you'll be able to know what x equals. Something plus 7 equals 12. However, they do start to get more difficult, so we need you to start looking at this method, the balance method. So in order to do it, what we need to do is keep each side of the equals the same, okay? And in order to do that, we need to use, what's the inverse of plus 7? So what's the inverse of plus? We minus. So if we were to minus 7 from this side of the equation, what's 7 minus 7? Well, that equals 0, so that cancels out. So that means we're just left with this x, which is really good. However, we want to keep the equation balanced. So because we subtracted 7 on this side of the equal sign, we must subtract 7 on the other side. So we've got to keep our equal sign there. 12 minus 7 is 5. Okay, so we know x equals 5 from doing that. So just to kind of highlight, this is our equal sign, okay? It always stays the same, stays there. What we had to do was subtract 7 on both sides to keep our equation equal, okay? And the reason we subtracted 7 is because we wanted to, we want to get rid of this x plus 7 here, okay, because we're trying to get the x by itself. We want to know what x equals. So in order to do that, we need to subtract 7. So we just did the inverse. So the opposite of plus, we subtracted. Okay, so we've got x by itself, so x equals 5. Let's do another one. So we've got x minus 4 equals 5. All right, so we're going to keep this equal sign underneath. Okay, it stays the same. Again, we want to know, what does x equal? Okay, at the moment it's got a minus 4 next to it. So we want to do the opposite of minus 4. So the opposite of minus 4 would be plus 4. Okay, and again, the reason we do that, we're doing the inverse operation because we were trying to get rid of this whole bit. Okay, because minus 4 plus 4 is 0, so they go away. So the x is left there, which is good. And again, to make sure the equation stays balanced, we have to do the same on the other side. So because we plus 4 on the left-hand side, we have to plus 4 on the right-hand side. So 5 plus 4 is 9. Okay, and we have our answer. Let's do C. 3x equals 18. All right, so we want to, again, get the x by itself. We want to get x equals something. Okay, at the moment it has this 3 here. Remember, when a number is next to a letter, it actually means that times. So 3x is actually saying 3 times x. Now, what is the inverse operation of times? What is the opposite of times? We would divide. So let's divide by 3. If we do that, 3 divided by 3 is 1. So that cancels out, which again, we're just left with the x, which we've got here, which is really good. But again, to keep the equation balanced, we have to also divide this side by 3. So 18 divided by 3 is 6. Alrighty, so again, very similar. You've just got to look at what's happening to that x. What operation do you need to perform on both sides to get that x on its own, so that we can find what does it equal. So here's another one, x over 5 equals 8. All right, at the moment, we've got x divided by 5. Okay, how do we get rid of that 5? It's dividing by 5. So the inverse operation to divide would be times 5. All right, so we do that so that that can get cancelled out. So we're left with the x. And to keep it equal, we need to also times 5 on this side. So 8 times 5 is 40. And we've just solved the equation. Right, if you ever need to check it, you can just substitute it back into the equation. So 40 divided by 5 equals 8. That is correct. 40 divided by 5 is 8. And 8 does equal 8. So that is correct. All right, so that's our solution to the equation. All right, next bit. So sometimes we have to do more than just that one step. So you need to be able to identify the correct order of operations, okay? You can't just get rid of any number first. It has to be in the right order. So let's go A. Complete this simplified flowchart. So the flowchart's there, okay? I. So we're doing this question. Which operation is performed first when backtracking? Right, so we have our flowchart here. We're backtracking, okay? So we're looking at the arrows going from right to left, and it says which one is the first one. So this here, going backwards, we're timesing by 8. So the operation that's first performed is times 8 when we're backtracking. Okay. 2, or I. Which operation is performed next to obtain x? Okay, so the next one, the next operation here is minus 5. All right, so you can always, if you're not sure which number or which operation to do first, you can set up your flow chart. B, it says copy and complete the steps shown at right to solve that equation. Okay, so we're going to do B here. X plus 5 over 8 equals 3. And we've just found in AI, the first operation we need to do with this one, we need to times 8 to both sides. Okay, so if we times 8 here, let's simplify it. If we're dividing by 8 and then we times by 8, that cancels out. So we're left with x plus 5. And we need to keep it equal, okay, across both sides. 3 times 8 is 24. Then, so we've just done this. The next step, we need to subtract 5. We found that by looking at our flow chart up here. So let's subtract 5 from both sides. All right, we know that plus 5 minus 5 is 0. So again, they cancel out. And we're left with x equals 24 minus 5 is 19. All right, so we've just solved this equation. X equals 19. And again, we can check. So to check, let's substitute 19 into the original equation. So does 19 plus 5 divided by 8 equal 3? Well, 19 plus 5 is 24. Divided by 8. 24 divided by 8 equals 3. And 3 does equal 3. So we did it correctly. All right, one more. So here's another two-step equation. Okay, it hasn't given us the flow chart. We need to decide what happens first. What do we need to get rid of? If I was setting up my flow chart, we always start with our x. All right, then what happens to the x? Then we times it by 3. It turns into 3x. Okay, I'm just setting up those flow charts which you've already done. And then we subtract 5. Okay. What does 3x minus 5 equal? It equals 22. Okay, so to come back, I'm just going to set up my boxes so it actually looks a little bit more normal. Okay, so eventually you guys won't need to do these boxes or flowcharts. You'll just get into the habit of what needs to happen first. Okay, but you can set up any equation like this to help you to know what next. So to go back, okay, we're going to go back this way. We need to do the opposite of minus 5, so we're going to plus 5. Okay, so 22 plus 5 is 27. And then we're going to do the opposite of times 3, which is divide by 3, which equals 9. Now, this is the flowchart method. We want to use the balance method. Okay, so you guys should get to the point where you can write your equation. So 3x minus 5 equals 22. Because we're really good at the flowcharts now, we know that we have to use the inverse operation to get rid of the 5. Okay, so instead of minus 5, we plus 5 to both sides. Okay, that cancels out, so we're left with 3x, which equals 22 plus 5, which is 27. Okay, a 3 next to a letter, that means times. So it's actually saying 3 times x. The opposite of times is divide. So we have to divide both sides by 3 to cancel that out. So x equals 27 divided by 3, which is 9, which is what we got over here. Okay, so these are two different methods. We're focusing on this one today. The better, or the more practice you can get at this, the better for the long run. Okay, so good luck.